Hello, once more. My name is Gus Cornell, and I am the cloud architect for Checkpoint for the Mid-Atlantic and Federal region. For us, cloud infrastructure as a service, which is what I do. We have public and private. On the private side, we support Cisco ACI, we support OpenStack, we support vCenter and NSX. And on the public side, we support Azure, Oracle, Google, AWS, and Ali Cloud today.
Nuage.
We also support Nuage, which really will fall here, and we support Nutanix, which also falls here. I just have not updated my slide, but thank you for mentioning that. That is indeed correct. So I can give a quick overview about CloudGuard, the solution, which actually applies to all these things simultaneously. This is all the same solution. You just get to pick where you want to use the solution in, or you can choose to use it everywhere if you want. We can concurrently have a single manager connecting to all these systems, and I'm about to say what we mean by that. The very first thing that I normally tell people, because NSX has a built-in firewall, the firewall, ACI has security services with the contracts allowing EPGs to talk to each other. In AWS, you got security groups. In Azure, you have network security groups. So the very first question that I get is, what is it that you're adding exactly security-wise to the cloud solution that I'm already using? And the very first thing that I tell people is that access control is not the same thing as threat prevention. What the DFW is, what the ACI contracts are, what AWS, what the Azure, they normally give you right out of the box is access control. You can define these machines can talk to these machines over this protocol, and that's pretty much what you do. But that's pretty much like the first guy on the airport security. He's looking at your boarding pass and looking at your ID. You have a requirement that you need to meet. If you meet that requirement, then you can step on inside the protected area. What we do is what the people in the background are doing. We actually deep inspect instead of the traffic. Of course, we tell you if there's any malware, if there's anything infected, if there's anything that shouldn't be there that's trying to spread internally. So that is usually the type of
and we also
distinction that
tunnel traffic, right? So
yes.
Because the open port 80 doesn't
exactly.
Somebody's not
hey, look, I got a bunch of stuff. Tunneling inside of DNS or inside of other protocols. Maybe somebody's doing cryptocurrency mining. Maybe you get malware propagating over the SQL ports, pretending to be SQL. If this were something like the DFW or the security group, all that is an open port. They don't know how long that connection is going to be open. They don't know basically whether it's the real protocol running over that port or whether there's something else. We can see that it's not SQL if something other than SQL is running over the SQL port. Yeah. If you have VDI users, we can actually protect those. If we do protection of exfiltration of data, so we can do full DLP at the network layer, or we can do URL filtering. If there's some contractors working inside of the cloud that are only allowed to go to bitbucket.org, or some places where they can get code snippets or download patches, you can allow them to do that. But if they try to connect to ESPN or watch the World Cup, then that's not allowed. We offer full, of course, IDS, IPS. That's part of our layer 7 detection, so we can see things like SQL injection attacks. If you have a perimeter, like a WAF, web application firewall, or an application gateway at the perimeter, that is perfectly fine and does deep inspection of web inbound traffic. We can do that as well, but we also do it on the inside, and we can see way much than just web traffic. We can pretty much see all ports and all protocols. We can let you know if TCP sessions are open for an inordinate amount of time, and I've seen sessions between two hosts open for almost a year and nobody even noticing about it. We can find out if somebody is on the inside is connecting to a bot or command and control site. We can find out people scanning inside of the network. If there are parts of the network, again, whether it's in a VMware environment, whether it's in a Cisco fabric, whether it's in the public cloud, that need higher compliance requirements, something like PCI or HIPAA or pretty much any additional compliance, we can add those extra compliance pieces and make sort of like a border, internal border between that section of the cloud, public or private, and the rest of the infrastructure. The very next question that I usually get is, okay, I have cloud, I'm using perimeter protection, and I'm using security groups or something to that effect, DFW perhaps. But for threat detection, I am using agents. I got workload agents. Maybe I have a log system that's telling me if something strange is happening. Why are you different than that? Exactly what can you do? So these are some examples. We do a lot of stuff in addition, but some examples will be, number one, we work at the network level. If you have an agent or the log notifying you that you are infected, it already happened. You already have to quarantine or destroy the VM. We can see the attack as it's moving through the network towards a target, and we can stop it over there. We can do zero-day detection and the document scanning. So if you have an application in the cloud that receives data from the outside, PDF files, maybe resumes, maybe quotes, it may be manuals, whatever, we can not only inspect that data, make sure that it's clean, we can also scrub it and remove malware that may be attached to it. I mentioned about the fact that we can do URL filtering and DLP from internal users going to the outside. And we have, of course, a lot more visibility than a plain NAT gateway, which is what somebody like AWS would give you. And a NAT gateway is what people use when they have cable at their home. That's not real security. If you have a data center and it's a legacy data center, I find that it's very frequently the case that the cloud version of that data center, the disaster recovery or backup site, needs to have exactly the same IP address space because the legacy application cannot deal with an IP address change. So we allow connectivity between the real data center and the DR site, even though they have overlapping IP address spaces, because we can do a double NAT during the connection and inspect the traffic while we're doing that. If you have remote access users, we can bring them into the cloud or into the area without the need of using Bastion hosts. And again, we can allow them on any protocol and do deep inspection on anything that they're trying to bring in or take out. If you're using us for transit connectivity, basically if your cloud area is segmented because you have higher compliance or because you have a developer side, a testing side, an operational side, we can link everything like most transit networks do. But unlike something like the Cisco CSRs, we actually inspect the traffic that's moving from one end of the cloud to another. So if there's any sort of threats trying to spread laterally, even over allowed ports like DNS, like SQL, like 443, we can see that there's an attack and actually stop. We can also integrate with Active Directory and things like that. We can do time-based access, like this particular user is only allowed to these resources for the next 3 months, or anybody can access these resources Fridays between 3 and 4, but not at any other time. So there's a lot of capabilities that we add on top of the regular cloud support. Okay, so things that are unique to us. The first thing that I mentioned is our manager can connect to all these things, but I didn't say what that means. We have IPI level integration with a lot of cloud infrastructures. That means when we connect to ACI, we are learning about the ACI infrastructure, the EPGs, the micro EPGs, the subnets. We pretty much interchange information with the ACI AP controller, and we learn about all those things. If we're talking to vCenter, we learn about the VMs that are part of the vCenter. We learn about IP lists. If we're connected to NSX, we learn about security workgroups. If we're connected to Amazon, AWS, or Azure, we learn about subnets, about VPCs, about VNets. We learn about VMs, about instances. We learn about tags that are part of those VMs and those instances. We learn about those changes and are aware of them within 30 seconds of that change happening. So if somebody adds a server to an EPG group in ACI, the checkpoint manager will see it within 30 seconds. If somebody tags a server as a database server on AWS, or just deploys a server and tags it, we will see that new server and we will see that it's tagged as a database server within 30 seconds. And that allows us to do some really nice things. The very first thing is dynamic enforcement. And we're not the only ones that can do dynamic enforcement, but we can do it better than anybody else today. And I'm going to tell you some examples as to why we can do it. In this particular example, we have two things. Number one, we just happened to pick an AWS instance and made it part of the rule. But most importantly, what we have here is we selected a tag. It could be a tag in AWS, a tag in Azure, for example, that says internet equal on or internet equal true, doesn't matter what that is. But if you have that, and you have that as part of a rule, says any source that has that tag can reach any destination over HTTP and HTTPS, and doesn't accept. That means that anything that you tag in the cloud that has that tag will automatically be allowed through this rule without you having to modify the policy rule or reapply the policy rule to your enforcement points. If you do a mouse over on your manager, when you have a rule like this, it shows you what it is. This tells you it's a dynamic object. We're learning it from a connection to a cloud environment. This tells you where that is coming from. In this case, this is an AWS object. We tell you what it is. This is an instance in this particular case. We tell you the last time that this tag was updated anywhere in your cloud subscription or account. We tell you any IPs that are associated with that tag. It can be a single IP or it can be 1,000 IPs. We don't care. We enforce it equally. And we tell you what tags, again, are associated with it. And this is basically live. By just doing a mouse over, you can see what that object is reflecting based on the cloud, and it's almost real time. Again, it's about 30 seconds, which is about twice as fast as anybody else can do. Yeah. And by that is, we can have a single manager talking to all these infrastructures at the same time. If we're connected to multiple AP controllers, we can learn about multiple EPGs, multiple tenants, multiple app profiles. Connected to multiple AWS subscriptions, we can learn all about their VPCs, subnets, instances, Azure, multiple Azure subscriptions. We can connect to all of these at the same time, multiples of these. Some applications, a customer had 2 data centers. They were running NSX on both sides, but the NSX that's on this data center did not know about the NSX security work groups on this other NSX. We could connect to both. We can do a policy that says anything on this NSX security work group X can talk to anything on this NSX security work group Y, and because we can talk to both, we can actually make that rule, even though a DFW would not be able to, because they can only see half of the entire network. The wonderful thing is, of course, and DC just mentioned this, anything that the manager knows, we push to the enforcement point, and we don't care what those enforcement points are. Exactly. It can be an Azure gateway, an AWS gateway, it can be an ACI gateway, it can be your perimeter, a physical firewall in front of your data center. It doesn't matter. If we know of an EPG group and we have a rule that says this EPG group cannot talk to this VM, and it happens to be a physical firewall in your data center that's in front of it, that firewall will know what that EPG group is, what the IP address members of it are, and it will stop a communication with that VM that you can define by name, because it will know what the IPs of that VM is. And so we can have AWS firewalls enforcing Azure tagged objects. We can have ACI EPG groups communicating with Azure or with anything outside of the Azure fabric, and that enforcement point outside of the Azure fabric will know what that EPG group is. Yeah. Since we're learning it, since the manager knows it, it means that it's also in the logs. Yeah. On other vendors will do some sort of dynamic objects, but all they're doing is collecting IPs. So you get this IP, try to talk to this IP, and we allowed it, or this IP, try to talk to this IP, and we denied it for this reason, right? We can show you not only the IP address, we show you where that object is being learned from. We show you the tags associated with that object. We show you the instance name of that object, if it happens to be an AWS object. We show you the VM that it's trying to talk to. So all that information that we're collecting from the cloud forms part of the logs. And you can do searches based on that. And I did an ACI demo, I want to say like 2 weeks ago. And we had some EPG groups that were connecting with other EPG groups. And then we went to the logs, and all we did was search on the EPG name, and boom, all the connections came on. And the Cisco engineer goes like, oh, that is neat. Okay, the question that I get often about our gateway enforcement points is how they are different from our regular appliances. And the answer is there's no difference. Basically, we're running the exact same OS. We're running the exact same software on them. So if it runs on an appliance, it will most probably run on the cloud. There are some differences that are imposed by the cloud itself. But for the most part, it's the exact same software. So all the functionality that you are accustomed to, if you're already using Checkpoint, is available exactly in the cloud. The last big difference that I want to point out is a RESTful API that our manager has. which allows basically anything that you can do from the dashboard graphical manager, you can do programmatically, which means that you can code in PowerShell, in Ansible, in Terraform, in Python, in any language that you are familiar or like, and you can issue instructions to the manager and pretty much do a lot of deployment and orchestration. And I have a video that I'd like to show, which is our security blueprint deployed in AWS. I did a playbook, and what the playbook does is it actually builds our environment on a blank AWS account. So I created the what we call the north of the VPC and added subnets to it. I added checkpoint gateways. I added Unix host. That is the manager that got added over there. I added a south VPC as well. All this is just a playbook creating all these things. I added a test network with 3 different VPCs. Then I populated all that with Windows systems, with Unix systems, defined the security groups, of course. I'm going to be adding internet gateways. There they are. And all this stuff is here. And the last step is collect all the dynamic IP addresses assigned by AWS. And once I collect all those addresses, I inject them into the manager using the API. And this is, of course, running accelerated, but within 20 minutes, I have roughly an entire deployment in AWS with multiple checkpoint gateways. Every single host that you see here was entered by the playbook. I did not do any of this manually. Not only did the host get entered, the connection to the firewalls was done, SIG was performed, the policy was pushed to the systems. In addition to that, I added policies, just 3 rules for the demo, but this could very easily be 500 or 1,000 rules. Yes. And the other thing that I did as part of this demo was I created a VPN community and inserted gateways that I created as center gateways and gateways that I created as satellite gateways, and pretty much had the VPN configured and ready to go. And all this was done basically using Ansible and talking to the Checkpoint API and something like AWS that also allows provision.
APIs.
Exactly. So you can build an entire data center and build your security exactly the way that you want it inside of the data center, and it will deploy the exact same way every single time. Yeah. So it's a pretty powerful stuff. And right now, we can issue instructions to the manager, and we can issue instructions to the gateways through the manager, because the manager is the one that has the API, but we're building the API recognition directly into the gateways themselves. So you won't need eventually to go through the manager to issue commands to the gateway. But you can do both today. Yes, you can just connect them directly. Correct. The next thing, you were talking about 10,000 rules. And one of the nice things that we have on our current version of the manager is we allow sub-rules. And when you select a rule, you can see the connections or the logs associated with just that rule. So if you have a rule that's been there for 6 months or a year, and you have no idea what it does, you can click on it and see every single connection that hit that rule on that history tab. By doing sub-rules, we also accelerate stuff, because you can have, instead of 10,000 rules, you can have 100 top rules, and each one of those could have maybe 100 rules underneath. So you have total 10,000 rules, but your packets only really go through the 100 top rules. And let's say they hit rule 99, then they go to the sub rules. So they just skipped over 7,000 rules in just 99 hops. So you get the speed increase, and you get the nice distribution of access control. Licensing. We have, I'm going to talk for 2 seconds about public cloud licensing, which is very different from what other people are doing. And then I'm going to talk a little bit about ACI and NSX. On the public cloud, we don't care how many gateways you deploy or how big the gateways are. We only care about the number of cores that you're using on our gateways. That's it. So you can license 100 cores, and you can use those 100 cores and deploy 20 of those cores in AWS, 20 of those cores in Azure, 40 of those cores in Google. As long as the total count of cores from all the clouds that you're connected to add up to less than 100, you're fully covered by those licenses. If you create a gateway in AWS that has 16 cores, and a month after you deploy it, you say like, hey, I don't need 16 cores. This thing is running at 2% utilization. I only need 4. You can reduce the size of that instance, and you get those 12 cores back into your license pool, and you can redeploy them in AWS, you can redeploy them in Azure, you can have an entire deployment in Azure and say, we hate AWS, we're moving, we hate Azure, we're moving to AWS. You can break it all down and redeploy those cores in AWS. You're fully licensed no matter where you're running those gateways. As a matter of fact, we support a lot of the same things in Azure and AWS, and the gateways themselves are not really configured differently. So it's very easy to move gateways from one public environment to another public environment. The last thing is the public cloud reference design. And it looks something like this. Normally, when we talk to customers, they show us the middle. Hey, we have a bunch of VPCs in AWS or a bunch of VNets in Azure or whatnot, right? We want to be able to protect the traffic that's coming in and out of those, but we don't want to necessarily stick a checkpoint gateway on each and every VPC. Exactly. How is the less intrusive way of protecting this? So we normally say, well, we would recommend that you create two VPCs or two VNets that are sort of sandwiching your system. The one on the top would check anything that's inbound from the internet. So let's say you have public-facing websites over here. Any traffic that's going through those will come in through the top, will hit a load balancer and an auto-scale system. So it doesn't matter where you start with a couple of 2-core gateways. You can make that auto-scalable. So you can start with 1 gig and then grow to 10 gig, grow to 40 gig. It doesn't matter. All that would auto-scale to the appropriate size. And then you can peer directly into the VPCs that are hosting the content, right? The reason we're able to peer is because we're doing NATing at the load balancer or NATing at the checkpoint. So as far as AWS is concerned, that is a VPC to VPC point-to-point connection. The bottom side is for internal traffic. So this is traffic that's moving between your headquarters and the VPCs, maybe from one VPC, like development VPC to production, or maybe development to test. It may be internal traffic that's going out. So anything that's going from the VPCs out into the internet. Maybe you have a direct connect or a full-blown MPLS WAN or SD-WAN connection that's coming to the cloud. That comes in through the South Hub, and from the South Hub, it gets inspected and sent to the appropriate VPC that it needs to go to. And we normally like to break it this way because we can scale them independently as well. So if most of your traffic is public traffic, that the upper powered scales. If most of your traffic is internal traffic because you're the DoD or whatever, and you don't have internet connectivity, then you can scale the bottom side appropriately based on that. Yes, and of course, we're doing deep inspection of packets moving in every direction, which is the goal. Anything that comes into the network, we deep inspect. Anything that's moving out of the network, we deep inspect. Anything that is moving east to west within the segments of the network, we deep inspect. And you can have those rules set any way that you want to, based on the Active Directory user, based on the application that they're running, based on the time of day, based on whether the developer or not, it doesn't matter. In this case, since some people do this, you can have a set of hubs dedicated for the direct connect, the connectivity back to headquarters, one dedicated for VPC to VPC, one dedicated for outbound, have different policies on each one, or you can have multiples, and then you pick which VPC is connected to which hub, and they can be connected to all of them. So the tags would be different. So if you want to connect to this one, this is a VPN community, so your tag would be the name of this community. But then you can add a tag to connect to this one, and that VPC will also connect to the other one. But I think what makes us the most popular is that most people have more than just AWS or Azure. They may have VMware, they may have ACI. You can control and see everything from a single console.